Good day and hello, sir. For today, we're going to present our research critique entitled Fiber Optic Technologies in Laser-Based Therapeutics Threats for a Cure. This is our introduction. Optical fiber technology has provided a great number of diagnostic and therapeutic tools for medicine in the past few decades. The unique form factor of optical fiber allows the transmission of signal and energy across microscale area or over kilometer long distance. These thin and flexible fibers have low calibers that can be inserted in the body through endoscopes or catheters, allowing clinicians to remotely perform imaging and diagnostic measures and deliver laser for treatment. For the summary, in the past decades, novel fiber structures and materials composition have led into introduction of a new diagnostic and therapeutical tools. We review the structure, the materials composition, and the fabrication process behind these novel fiber system because of their structural flexibility, their com- compatibility with endoscopic appliances and their efficiency in laser delivery. These fiber systems have greatly extended the reach of a wide range of surgical lasers in minimally invasive procedures. Much research in novel fiber optics delivery system has been focused on a accommodation of higher optical powers and the extension to a broader wavelength range.
For our critical evaluation, in the past few decades, surgical laser systems have evolved into a large range of specialty laser systems. Their wavelengths span from deep ultraviolet, such as 193 nanometer for excimer ARF lasers, to mid-infrared wavelengths up to 10.6 meter for CO2 lasers. The range of the power density extends from several milliwatts over a centimeter squared used in photodynamic therapy to TW over centimeter squared used in a plasma-induced ablation and a photo disruption. Laser tissue interaction using fibers as a delivery optics for laser surgeries requires the fiber geometry and materials to be tailored to laser wavelengths, energy densities, and power density. Traditionally, fiber materials are largely determined by the optical observation, thus the specific laser wavelengths and their damage thresholds in comparison to the power level required by the application. Fabrication processes most optical fibers regardless of their structure and composition are produced through the two-stage terminal drawing process that was developed in 1970s for silica fibers used in telecommunications. In first stage, microscopic rod is prepared that has the geometry, structure, and refractive index profile of the desired optical fiber. In other words, this rod or preform as it called is desired optical fibers but on a much larger scale. The main reason to preform is prepared to have drawable materials that is clean, expensive, low in hydroxyl concentration, and metallic ion contaminants in the case of silica fibers. Conclusion: While fiber optic technology has well penetrated many fields in medicine, contingent engineering refinement will undoubtedly bring a higher level of functionality and many authorization. Future fiber optic laser deliver systems will likely use both novel structures and material composition to widen the range of deli- deliverable wavelengths and power levels for surgical lasers. Single fiber device capable of transmitting multiple lasers at different wavelengths could simultaneously provide high throughput ablation, excellent coagulation and high precision without a trade-off in a single wavelength system. The future direction of optoelectronic technologies is discussed while emphasizing what is needed to establish collaboration between photons and electrons in a single system. Drastic improvements and even new function will be obtained with systems that combine the best features of both electronics and photonics. Optical interconnection in computers are just the first indication of photoelectronic integrated systems. In the optical interconnection in microprocessors described in the article will constitute the basis of photoelectronic integrated system. Technologies for integration of micro optoelectronic devices with microelectric integrated circuits will be the key to the photoelectronic integrated system. A variety of optical systems should become feasible upon introduction of electronic circuit in many parts of such system, where logical operations are required. Conversely, introduction of optical circuits into electronic systems will result in the revolution of system function. So that is our that is our report for our research paper or research critic. Thank you very much.